Hello, good day everyone. Welcome to my YouTube channel. And in this video, we are going to simplify this question for x, and we have a 7 raised to the power sine square x plus 7 raised to the power cos square x. This is equal to 8. So let's start. In the first step, we use this identity, which is a cos square x. This is equal to 1 minus sine square x. So in the first step, we replace this cos square x by 1 minus sine square x. So we have a 7 raised to the power sine square x plus this is a 7, and we write this cos as a 1 minus sine square x, which is equal to cos, and this is equal to 8. Now in the next step, we use this identity, which is a raised to the power n minus m. We write this as a raised to the power n multiply a raised to the power minus m. So we apply this property on the second term. So we have a 7 raised to the power sine square x plus this is a 7 raised to the power 1 multiply 7 raised to the power sine minus sine square x. This is equal to 8. And in the next step, we let that 7 raised to the power sine square x, this is equal to w. Then this implies 7 raised to the power minus sine square x, this is equal to 1 over w. So the above equation will become a w plus 7 raised to the power 1. 7 raised to the power 1 multiplies 1 over w, this is equal to 8. Now in the next step, multiply this equation by w on both sides. So this w and w will become a w square plus 7 raised to the power 1 is just 7. We write this as a 7 over w. Multiply this by w, it's equal to, this is a 8 times w. Now we write this as a w square plus this and this cancel. We just get a 7 is equals to 8 times w. And in the next step we subtract a 8 times w on both sides of this equation. Then we have a w square minus 8 times w plus 7. This is equal to 0. And this is a quadratic equation. So we use a quadratic formula, which is our w is equal to minus b plus minus square root b square minus 4 times ac over 2a. And in our equation, a is equal to 1, b is equal to the coefficient of a w, which is a minus 8, and c is a constant, which is a 7. Now we substitute this value in this formula. So we have a minus, and b is a minus 8 plus minus b square mean minus 8 square, which is a 64 minus 4, a is a 1 and c is a 7 over 2 and a is a 1. Now simplify this. So we have a minus and minus will become a positive. So we have a positive 8 plus minus 64 minus multiply 4 by 1, we get a 4. Multiply this 4 by 7, we get a 28 over 2 ones are 2. Now we again simplify this. So 8 plus minus 64 minus 28 is a 36 over 2. So we have a 8 plus minus square root 36 is a 6 over 2. Now question, w is equal to 8 plus 6 over 2, and the second value is 8. W is equal to 8 minus 6 over 2. Now we simplify this. So W is equals to 8 plus 6 is a 14. Divide this 14 by 2, we get a 7. Now we simplify this. So 8 minus 6 is a 2. Divide this 2 by 2, we get 1. So we get the two value of W, which first one is a 7 and the second value is 1. Our two value of w. First one is a 7 and the second value is 1. Now we take this value. So we let that 7 raised to the power sine square x, this is equal to w. So we have a 7 raised to the power sine square x, this is equal to, we take this value, so we have a 7 and we write this 7 as a 7 raised to the power 1. Now look at this, the base is same. So this implies we can compare their exponents. We have a sine square x, this is equal to 1. To remove this square, we take a square root on both sides of this equation. So we take a square root on this side and also take a square root on this side. So this square and square root will cancel. We have a sine x and the square root 1 is a plus minus 1. And we write this as a sine x, this is equal to 1. And we separate this value, sine x, this is equal to minus 1. Now we write this as a x is equals to sine inverse of 1, which is equal to 90 degree, and in radian we write this as a pi over 2. And sine is positive in first quadrant and in second quadrant, and for first quadrant the value of x is a pi over 2, and we add the period of pi, which is a 2k pi, and here k belong to a integer. And sine is also positive in second quadrant, and so for second quadrant the value of x is a pi minus pi over 2, and add a period of its to k pi, and k belong to integer, we already discussed. Now we simplify this, then we get pi over 2, and this is a 2k pi. In this case our final answer is a pi over 2 plus 2k pi. Have this, simplify this, we get a x is equals to sine inverse 1, and we discuss this negative sign later. And sine inverse of minus 1, this is equals to minus 90 degree, and we write this as a in radian minus pi over 2. Sine is negative in third quadrant, so for third quadrant x is equals to is a minus pi over 2 plus 2k pi, and k belongs to a positive integer. For fourth quadrant, the value of x is a 2 pi minus pi over 2, plus we add its periods to k pi. Now we simplify this, then we get x is equals to 3 pi over 2 plus 2k pi, and k belong to a positive integer. So in this case we get two value of x. First one is a minus pi over 2 plus 2k pi, and the second value is 3 pi over 2 plus 2k pi. Now we solve this part. So we let that 7 raised to the power sine square x, this is equal to w, and this case this is equal to 1. So in the next step we write this side as a 7 raised to the power 0, which is also equal to 1, and we copy the left hand side. Now in this case the base is same, so we can compare their exponent. So this implies sine square x, this is equal to 0. To remove this square, we take a square root on both sides of this equation. So this square and square root will cancel. So sine x square root 0 is a 0. Now we write this as a x is equals to sine inverse of 0, and sine inverse of 0 is equals to 0. So in this case the value of x is a 0, and sine is positive in this case, and so sine is positive in second and first quadrant. Now we find the value of x for first and second quadrant. For first quadrant, the value of x is a 0, so we add its period, which is a 2k pi. And for second quadrant, the value of x is a pi plus 2k pi. And in this case, k is belong to a positive integer. We write its solution set. So the value of x is pi over 2 plus 2k pi. The second value is minus pi over 2 plus 2k pi. Third value is 3 pi over 2 plus 2k pi. The fourth value is pi plus 2k pi. Solution set k belong to a positive integer. So this is our final answer and we have done.